NASA has just successfully landed its most ambitious ever mission to Mars. After a 7-month journey through space, the rover, called Perseverance, survived a perilous high-speed plunge through the Martian atmosphere and made it safely onto the surface of the red planet.
They say that once you grow crops somewhere, you've officially colonized it. So, technically, I colonized Mars.
For thousands of years, Mars has glowed in our night sky, like a distant mystery, a world close enough to tempt our imagination, yet dangerous enough to remind us of our limits. Today, that mystery is slowly unfolding. Rovers crawl across the Martian dust, satellites map every canyon and crater, and humanity prepares for the boldest mission in its history, sending humans to Mars. From robotic pioneers to futuristic terraforming plans, Mars isn't just a planet, it's our next frontier. Before we dive into the story of how we explore, survive, and transform the red planet, robotic pioneers, the rovers on Mars. Mars exploration began not with humans, but with robots. Small, durable, incredibly intelligent machines designed to survive a world colder than Antarctica. NASA's rovers Sojourner, Spirit, Opportunity, Curiosity, and Perseverance have rewritten our understanding of the red planet. Spirit and Opportunity revealed ancient signs of water, Curiosity uncovered organic molecules, and Perseverance carries instruments capable of searching for ancient microbial life. These rovers drill samples, study rocks, examine atmosphere, and send back breathtaking landscapes. Each rover is not just a robot, it's a scientist, explorer, and survivor telling humanity the secrets of an alien world. Orbiters and mapping systems. Before humans ever step foot on Mars, orbiters have mapped nearly every inch of the planet. Spacecraft like Mars Reconnaissance, Orbiter, Maven, and Mars Odyssey provide high-resolution images, weather data, radiation measurements, and atmospheric behaviour. These orbiters help scientists pick safe landing zones, understand dust storms, search for underground ice, and track seasonal changes. Their observations act like a GPS system for future astronauts, guiding them through the harsh Martian terrain with unmatched precision. Human missions. The next giant leap. Sending humans to Mars is one of the most complex missions in history. Astronauts will travel 6 to 9 months through deep space, protected by radiation shields, advanced life support systems, and artificial habitats designed for long-duration survival. Upon arrival, crews will need landing technologies capable of handling Mars' thin atmosphere far too weak for parachutes alone. SpaceX's Starship, NASA's Orion, and international mission plans all aim to achieve this monumental goal. Humans on Mars will conduct scientific research, build habitats, set up energy systems, and test technologies needed for permanent settlement. The first human mission to Mars will not just be a milestone, it will redefine what humanity is capable. Building Martian habitats. Living on Mars requires innovation, unlike anything ever created. Astronauts will need radiation-proof shelters, air filtration systems, food production units, and reliable water extraction. Habitats may be built using 3D printers that use Martian soil as construction material, reducing the need to bring supplies from Earth. Underground lava tubes could serve as natural shelters against radiation. Solar fields and nuclear reactors will provide energy, while greenhouses will grow food using recycled water and nutrients. Every piece of technology must work flawlessly, because Mars doesn't forgive mistakes. Life support and survival challenges. Mars is a planet where everything is hostile. Freezing temperatures, toxic dust, thin atmosphere, and constant radiation. Astronauts will rely entirely on systems that recycle air, water, and waste. Oxygen may be extracted from carbon dioxide using machines like MOXIE, while water could be pulled from underground ice layers. Human survival will depend on closed-loop ecosystems, robotic assistance, and constant monitoring from Earth. Each challenge we overcome brings us closer to becoming a multi-planet species. Terraforming Mars. Turning red into blue, terraforming Mars is one of the boldest ideas in science. Transforming a cold, dead planet into one humans can live on without spacesuits. The concept includes heating the planet, thickening the atmosphere, melting ice reserves, and releasing greenhouse gases to create a stable climate. Some ideas propose giant mirrors in orbit to warm the surface, while others imagine releasing trapped carbon dioxide to thicken the air. More futuristic concepts include genetically engineered plants that produce oxygen or massive factories designed to reshape the atmosphere. While these ideas remain theoretical, they spark imagination and guide future research. Mars represents survival, science, and exploration. It is a backup world for our species, a laboratory for discovering life, and a platform for advancing technology. Exploring Mars protects humanity from extinction-level events, pushes scientific boundaries, and unites nations in a shared dream. The path may be difficult, the risks enormous. The deeper search for life on the red planet Mars is a silent witness to a past that may have once been brimming with life. Beneath its dusty surface lie rocks, sediments, and chemical structures that tell a story billions of years old. Each rover sent to Mars carries an unprecedented mission: to uncover traces of ancient life. Mars was not always the frozen, barren desert we see today. Billions of years ago, vast lakes and rivers carved the surface. Thick clouds once floated overhead, and a magnetic field shielded its environment. The rovers drill, scoop, and analyse the very layers that may hold microbial fossils, organic molecules, and mineral signatures of life. Perseverance is equipped to detect even the smallest biosignature, scanning for microscopic structures invisible to the naked eye. The samples collected on Mars could one day be returned to Earth, where superpowered laboratories will dissect their composition, searching for proof that life existed beyond our planet. Finding even the tiniest trace would redefine humanity's understanding of life, evolution, and our place in the universe. Life on Mars would prove that life is not unique to Earth, but a cosmic pattern waiting to emerge wherever conditions allow, preparing humans for the most dangerous journey. The voyage to Mars is more than a flight. It is a test of human endurance, both physical and psychological. Astronauts preparing for Mars undergo years of intensive training, simulating every possible scenario they might encounter. They live in isolated habitats for months, managing conflict, boredom, and stress without external support. Their physical conditioning includes extreme cardiovascular challenges, strength endurance, and emergency medical training. They learn to repair complex systems, operate autonomous vehicles, and respond to life-threatening situations in real time. Psychological resilience is equally important. Mars is a lonely world, and the mental toll of isolation, confinement, and distance from Earth can be deadly. Every astronaut must become a doctor, an engineer, a mechanic, and a leader, capable of handling life and death situations independently. Landing on Mars represents another monumental challenge. The planet's thin atmosphere makes deceleration almost impossible. Advanced AI, precision thrusters, hazard-detecting cameras, and retro-propulsion systems must all work flawlessly to place humans safely on the surface. Any miscalculation during entry or descent could result in catastrophic failure, making the mission a high-stakes test of both technology and human skill. Human habitats engineering life on an alien world. A human habitat on Mars is a fortress and a laboratory, simultaneously. Radiation from cosmic rays and solar flares is relentless. Temperatures plummet to extremes far colder than the coldest regions on Earth, and dust storms can cover entire continents. Oxygen must be generated continuously. Food must grow in closed systems. Every habitat is an ecosystem, engineered to sustain life under conditions hostile to humans. Some habitats will be built inside natural lava tubes, providing natural shielding from radiation and extreme temperatures. Others will be 3D printed from Martian regolith, creating walls strong enough to withstand storms and meteorite impacts. Life support systems will recycle air, water, and nutrients in continuous loops, and energy will come from a combination of solar panels and compact nuclear reactors. On Mars, homes are not luxury. They are survival machines. Yet within these walls, humans will slowly adapt to a new normal, turning the alien landscape into a home. Agriculture on Mars, creating life in a dead world. Mars has no soil suitable for growing food. Its surface contains toxic perchlorates, and the atmosphere is unbreathable. Yet growing food is essential. Advanced hydroponic and aeroponic systems will allow plants to thrive without traditional soil. Bioregenerative farms will recycle water, nutrients, and oxygen, providing both sustenance and life support. Plants will convert carbon dioxide into oxygen, stabilize humidity, and help maintain the internal ecosystem. Scientists are developing genetically modified species that can survive lower pressure, reduced sunlight, and extreme temperatures. Agriculture is not just about food. Terraforming Stage 1, warming the planet. Liquid water and plant life require higher temperatures. Strategies include deploying orbital mirrors to focus sunlight on the surface, releasing greenhouse gases, and sprinkling dark dust on polar ice caps to increase heat absorption. Controlled release of our subsurface gases may accelerate the process. Over centuries, these interventions can melt ice, thicken the atmosphere, and gradually make the climate more habitable. Warming is slow, but it is the critical first step toward transforming the planet. Terraforming Stage 2, thickening the atmosphere. To support life, Mars needs a denser atmosphere. A thick atmosphere protects from radiation, stabilizes climate, and allows liquid water to exist. Atmospheric buildup may include large-scale gas release, artificial volcanic activity, and bioengineered microbes producing greenhouse gases. Over time, pressure will increase, storms will stabilize, and Mars will move closer to Earth-like conditions. This stage requires planetary-scale engineering and decades of continuous effort. Terraforming Stage 3. Creating oxygen is the final goal. Achieving breathable air on Mars requires global bioengineering. Algae oceans, genetically engineered microbes, and artificial leaf technology will generate oxygen. Massive reactors will split water into hydrogen and oxygen, gradually enriching the atmosphere. This stage will take thousands of years, but it is scientifically plausible. When complete, humans may one day walk freely without suits, under blue skies and flowing rivers. Future Mars, humanity's second home. Imagine a terraformed Mars centuries from now. Cities under protective domes, rivers restored to their ancient paths, forests breathing life into the landscape. Children born on Mars will be taller, adapted to lower gravity. Farms will stretch across plains. Schools will teach the history of two worlds, and humans will develop a culture independent of Earth. Mars will not be a backup. It will be a new branch of human civilization, a second origin story. Once barren and cold, Mars will echo with life and human achievement. Mars is distant, dangerous, and unforgiving, yet it holds the greatest promise for human exploration. Rovers have charted the way. Humans will follow. Terraformers may one day reshape the planet itself. If you want to witness this extraordinary journey, subscribe now. Hit the bell icon and join humanity's adventure on the red horizon of Mars.